Hello, hope you're having a great day so far. Today, I wanted to make a special video about something I believe is really important in mathematics. In fact, I would say it's one of the secret ingredients for mathematical success moving forward. It's something that some people have already mastered, some people have not, but I think it would be really good to bring it up and then explain why I think it is one of the secret cheat codes to getting really good at maths. And that is times tables. Now, you may not have thought that this would be the secret ingredient of success when you heard it, but in fact, I believe times tables is so underrated, especially learning them, memorizing them, having a quick recall, being able to say 5 times 3 is 15, 4 times 5 is 20, and just knowing at the top of your head what the times tables from 1 to 12 usually. Now, I'm going to take a little bit of time just to explain why I believe times tables is so powerful. Knowing your times tables in maths will allow you, I believe, to open up a whole new sphere or in terms of not necessarily a whole new sphere, but just allows you to learn mathematics in such a more efficient way. First reason is that the times tables are fundamentals, foundational skills that touches so many different strands in mathematics. And by knowing your times tables just without having to think about it, you're actually opening up, or you're actually allowing your brain capacity to be used in full when a new concept is being taught to you, instead of only using, say, half or a quarter of it and using the rest of that trying to process just simple times tables that you should just be able to memorize. I think mathematics has a bad rap, and sometimes people think, memorizing something in mathematics is a bad thing because just because you memorize it, you don't understand it. And that's true. If you don't understand a mathematical concept, you should seek to understand it. But it doesn't mean we should take away the memorizing aspect of it. I'll give you an example. I was an avid basketball player when I was a child, and I remember that I had to learn how to play at the very beginning. And one of the things that I found really, really hard to do at the very beginning, and I saw that all of these players doing these really cool moves where they would bring the ball up the court and then put the ball up and do a layup, basically running to the basket and throwing the ball up and getting the ball in. And I remember wanting to do that skill, so I would try and, bring the ball or dribble the ball in and put that ball up, and the ball would not even get to the hoop because I didn't even know how to dribble yet. And I guess, I tried learning and learning and learning. I never got there until, I was suddenly had a coach, suddenly understood a little bit more, and the coach just forced me every single time that I had training session with him to just dribble the ball, right hand, left hand, moving one hand to the other, to the point where I no longer needed to even look at the ball. And now I knew where the ball was just by putting the ball on the floor and knowing where the ball's going to bounce back up again. As soon as I knew how to dribble the ball without even thinking, suddenly I could now learn new skills like bringing the ball up to the hoop or bringing the ball to the three-point line and taking a shot, because I wasn't thinking about something, or I wasn't using all of my brain space trying to keep the ball, or looking at having my eyes fixed just on the ball and not seeing anything else. I could get rid of that. That was instinctual, memorized, understood, and then I could use all of my capacity to then learn a new skill that required that foundation to be in it. It's the same thing with you who learn music. As soon as you learn music, you learn these drills. I guess maybe drills is the wrong word, but you learn how to do scales, you learn your chords, you learn your notes, you learn to read music, and suddenly it becomes second nature. You don't have to think about it. I know that for me as a simple guitar player, learning how to play chords, as soon as I knew my chords and the pattern my finger had to be on the fret to be able to do that, I didn't need to think about it anymore. I just need to know the rhythm, the order, how I should sing when I'm playing, and I'm not thinking about the basics anymore. I think a lot of you who have not learned your times tables and memorized them are taking a lot longer to learn a new concept because you're taking so much of your brain space just working out simple calculations, when if you just spend a bit of time learning your times tables, it will actually unlock a whole range of space in your brain to be able to do this work. I'm going to actually show you where times tables come up, and you may just think about this and go, oh, I never really thought about that. Or you may be going, oh, actually that's true, that I did already know that. But let's think about some places that times tables may show up. So let's look at where this can go. Well, first thing is, we know that multi-digit multiplication requires times tables, obviously. So if I had 329 times 5, okay, if you didn't know your times tables, this is going to take you a long time. It might take you even a long time to learn this, because you're so busy spending your energy going what 5 times 9 is, when if you can have quick recall, you go, well, 5 times 9 is obviously 45. And then when the teacher is teaching you about, oh, then you have to carry the 4 because it's 45, you have enough brain capacity to understand that. And then of course you can go 2 times 5 is 10 plus the 4 is 14, and then put the 1 on top. 2 times 5 is 15 and 16. So with your times tables, multi-digit multiplication becomes straightforward. Without a full understanding of it and memorization of it, it actually makes it harder to learn. And of course, it carries then through to division, because you have 324 divided by 3. And I'm asking questions like, how many times does 3 go into 3? Well, that's easy. You know, if you don't know your times tables, that's still okay. But then I go, how many times does 3 go into 2? Well, you can't. 2 has to carry forward. How many times does 3 go into 24? That's, even though it's division requires your times table knowledge, because you're asking the question, how many times does 3 go into 24? And of course, that is a multiplication question. You're asking 3 times what is equal to 24, which is a times table problem. And if you knew your times tables, this 8 comes up straight away. If you don't know your times tables, you're thinking a while before this answer comes, and your brain space or capacity is not being used understanding the concept of division itself. Then we go to powers, and powers is multiplication as well. We got 3 to the power of 2, and we go, well, that's 3 times 3 because it's 3 multiplied by itself twice. So here we go, and that equals to 9. Times tables right here, 4 to the power of 3, okay, that's 4 times 4 times 4, okay, is equals to 1. And of course, if you knew your times tables, this is really straightforward. That's 4 times 4 is 16 times 4, right? And then you can just go, well, 16 times 4 is, I believe it's 50, or 24, no, it just ends with 4. And then you have 64. That's times tables, okay? That if you knew that, your times tables, that's straightforward. Then of course you have factors and multiples. And of course, then you have, well, factors and multiples. We're asking the question like, well, what are the factors of 15? And now if you can only really do this because you can go, well, I know that 3 times 5 gets me 15, so those are factors. I know that 1 times 15 gets me 15, and those are it. And of course, you're going to get bigger ones as well, but you only know this if you know your building blocks. Okay, otherwise you're spending so much time asking the question. I'm asking you what multiplies together to get 15, and you spend so much of your brain power trying to figure that out that you actually didn't have the ability to learn what a factor actually is. Same with multiples. We have, what's the multiples of 9? It'll be really easy if you know your times table. So it's 9, 18, 27, 36, okay? That's times tables. Once again, you can then go, well, we've learned also HCF, which is highest common factor, lowest common multiple, and we learned this for a specific reason too. I'll show you that later. But you're asking questions like, well, what's the highest common factor of two numbers like 25 and 30? And then you would have to actually know the factors of these numbers, and then understand that the highest common factor is the common factor that they share that is the highest. Think about the concepts you have to learn. The common, highest, and then you have to then go into factors, which you have to need your multiplication for. So it's a lot. It requires, some of you are already, hopefully this is already clicking. This is why it's so hard for me to learn these concepts. I remember learning about highest common factor. I remember learning about lowest common multiple and just being like, you might be thinking, and just being like, I don't understand. It doesn't make sense to me. It's because you're spending so much of your brain power skip counting, or so much of your brain power trying to recall some information that you haven't fully learned yet. And so by the time the teacher explains to you what a factor is, what common means, and what highest means, you've lost it, and you haven't been able to pick that back up. Whereas if you know your times tables, you're not thinking about those things anymore. You're just thinking about, oh, common means the same, highest means the highest, and I know what factors these have. I know this has a factor of 5. I know this has a factor of 5, and I know there's no other factors that are higher in both. So the highest common factor is obviously 5. Okay. This is something then, of course, you know you need highest common factor and lowest common multiple when you do fractions. When you're adding fractions together. Okay? Or I guess maybe I won't even use 7. Let's use something else. Let's use 15. Okay? If you don't know your highest common factor, you don't know which number you should multiply, or at least you'll take a bit of time, a long time, trying to figure out what I should be multiplying. And so some of you know the trick of just multiplying the other denominator, but if you know your times tables, this is so straightforward because highest common factor between these two numbers, if you know your times tables, is 5. So why don't I just multiply this by 3? And so I know that if 5 times 3 gets me to 15, then I won't need to multiply this by anything. And I know that this is 9 over 15 plus 2 over 15. Okay? All right, but then also, of course, you have just basic fraction multiplication. And that takes a bit of work too. I teach you fraction multiplication, or fraction division even, and I'm trying to teach you KFC or keep, flip, change, but you're still stuck on the multiplication table. So this is 3 over 5 times 7 over 2. And of course, this is just multiplication. 3 times 7 is 21. 5 times 2 is 10. But imagine if you don't have your times tables, this is taking you a lot of time to work on, and you're feeling frustrated in class because you're thinking, why is everybody else doing this so quickly, but when I'm doing it, it takes me so long. It's not because you're not as smart as them. Sometimes that's what you guys think. It's like, I'm not a math person, I don't feel as smart. It's because some people have learned their times tables and they've just been able to do this without having to think. They've got the fundamentals down and they're learning a new skill that requires this fundamental, and so they don't need to take so much time on the fundamental skills. They just already got that instinctually in them. You can do that as well and actually increase your ability in your mathematics to learn it as well as you can. Percentage of numbers, 25%, or let's make something easier even, 30% of, let's go 10. Okay, this is straightforward. I know 30% is 0.3 times 10, and I know how to do this because 3 times 10 is 30, and this decimal point, remember this is decimal multiplication, and decimal multiplication requires you know your times tables. 3 times 10 is 30, with the decimal point means I move it back, so this is just equal to 3. Okay, see that even percentage, decimals, goes into multiplication, goes into times tables, even integer operations goes into times tables. So remember, we were learning stuff like, well, a negative number and a positive number multiplied together turns into a negative number. Imagine I'm teaching you this skill, but you're so busy trying to figure out what 9 times 3 is, you've already lost the ability, or maybe I shouldn't say you've significantly disadvantaged yourself, because I'm trying to teach you negative number times a positive number is negative number and showing you how, but you're looking at 9 times 3 going, what is 9 times 3? I don't know. I had to actually skip count this, use my fingers. If you learn your times tables, you won't need to do that. Then we got statistics, then we got algebra, then we got measurement. Remember, area is equal to length times width. Okay, that's times tables right here. Algebra, 3a times 5a is equal to what? Well, that's times tables because you've got to multiply these two numbers together to get 15, and then that's a squared. We have statistics like finding the mean, like what's 3 plus, or add all the data together. Okay, and this is this is all plussing together, and we had to divide this by 5 because it's 5 pieces of data. So this is 6 plus 10 plus 4, which is 20 over 5, which is, by the way, this is division, and division requires you to once again ask the question, what times 5 gets me 20? So 5 times what gets me 20? And of course that answer is 4 if you know your times tables, which means that this is equal to 4. Whoops, 4. And the only way you know that is if you know your times tables well. At least I shouldn't say that. The only way you're going to know that instinctually and quickly is if you know your times tables. A lot of you are working hard to figure that out, but like I said, take 10 minutes a day working on your times tables. If you don't know them off by heart, learn from 1 all the way to 12. Start with the ones that you find difficult. If you get your multiplication tables down and you haven't already, this might be your big break. This might be the opportunity for you to catch up on the mathematical learning that you have not been able to do as efficiently because you haven't had the fundamental skills down. So can I plead with you? Learn your times tables. It's going to be awesome for you, and you'll find yourself in a better place when you're learning. I hope this video helps and explains it. You can share it with people if you want to, but otherwise I hope I made a convincing case for you to learn your times tables.